Great. And Professor Ren, it's all yours.
Great, thank you. Hello, everybody. Good afternoon. It's really exciting for me to have this chance to meet all of you virtually and to share a little bit about my research area and try to kind of deliver some of these critical thinking and insights that we apply when we work on our research problems. There's so many things happen for artificial intelligence and machine learning these days, but I want to just pick a very kind of a specific and relevant angle for all of you. So I'm going to talk about today for how these social media platforms, especially those apps companies, are trying to understand and predict the user engagement over those apps. And I won't be speaking for many different companies. I know you guys have different preferences and you might be using something more than the others. But it seems I have some experiences with Snapchat because I do a consulting in the company for over a year there. So I know exactly what they were playing with for understanding users. So I would go from that angle. Okay. So a little bit about myself first. I'm assistant professor at the computer science department at USC. I haven't been a faculty for very long. It's actually just the starting of my third year. And it's actually my very first experiences interacting with high school students. As I said, I'm very excited for joining this program. I did my doctoral study at the University of Illinois at Urbana-Champaign, where I also studied computer science for like 5 years. And then I spent a year at Stanford University to continue on some collaboration projects. After I started in USC, in my second year, I spent a part-time at Snapchat because I feel like very excited to know about what kind of data the company has and what can I do by applying my research expertise to help with their products. So that's a very useful experience and also kind of motivate me for sharing this today. Regarding my research interest, I actually teach and do research on the topic called natural language processing. You can think it as a kind of a sub area under artificial intelligence under computer science. So a very kind of a good example for talking about NLP I always would like to use is to think about this like a smart chatbots or these are intelligent assistants that you can find on your smartphones. For example, Siri for Apple. You can talk to them and then you can ask them to do something for you, like call someone or FaceTime with someone or even like read emails for you or something else, right? There's actually a lot of things happening under this seems very smart interface. And many of them are related to natural language processing. For example, they need to understand what you are saying by doing speech recognition. That's a voice to text kind of translation. And then they need to understand what's the topics you are talking about. What is your intent when you talk to them, right? Are you trying to make a call or even order some food? And they need to learn to understand your questions and try to answer them. For example, you ask them about what is the weather today looks like. They need to understand the question. They also need to find out that where you are locating, right? And they need to talk to you back and forth. That's a dialogue processing. And they need to speak out from what these smartphone machines are internally represent into some kind of natural language speech sentences. So there's a lot of things happening here. But one of the core techniques happening in this natural language processing applications is called machine learning. Again, I'm going to use a very straightforward examples to just give a very kind of a preliminary introduction about what is machine learning looks like. So in a very high level manner, the machine learning is like showing some examples to what we call model and hope the model can mimic the human's behavior in solving some task. Let's say I'm trying to teach a machine how to recognize images of apples. I will fit the model with a bunch of Apple images. They look in different shape. They are in with different backgrounds. Some are on the cheese, some are on the hand, some are on just market. They're with different colors, different shape, and you have different lighting when you take the picture, right? But with all of these different pictures, there will be human look through all of the pictures and tell and confirm that, okay, these are apples. They are not oranges or other stuff. So these are the annotated examples which are fit into a model. There's a lot of stories behind the model here, but I'm not gonna go into details today. But this model eventually, or hopefully, can learn to recognize apples. And the nice thing is, once you learn such a model, you can deploy the model to a bunch of places, right? You can put it on your smartphone. So every time you take out your phone, you take a picture, the picture might be automatically classified into whether it's an apple or it's a person or something else, and then they will be very smartly placed in different categories in your album. And that's one of the reasons why you see in the let's say if you're using iPhone, why the system can put your once you search for keywords, why these images can pop up that are relevant to your keywords. That's what is things happening underlying. Okay, so that's just one simple example of machine learning, but these techniques has been applied to all of the previous examples that I talked about. For example, let's assume you are a market researcher that you want to understand user satisfactions with some products, right? Let's say a cell phone. So you want to build a model to scan through, let's say, Amazon reviews, understand whether people think highly of the products or not, right? So in order to build such a model, again, you need some examples that are annotated, validated by human, and hopefully a model can mimic what humans think about good products versus bad products when they write the reviews. So if you say you fit this review, like a bunch of reviews talking about like, this is frustrating, never works, not once and again, we'll wait for next release, then this is very likely negative sentiments, and that's what human can annotate for to label this data. And that means it's a lower satisfactions for such kind of products, right? When you read these reviews. In opposite, if you see reviews like, whoa, amazing, saved me a lot, more than happy to, then human can easily tell that's a positive sentiment is implying higher satisfactions, right? So if you can learn a model that understand these language patterns, and in the future, this model hopefully can automatically read through the Amazon reviews and try to pick out, oh, this is a very well satisfying product, and that's not, and you can think about some solutions to improve the products by monitoring such reviews. That's a very useful feature. And such a task, technically we call this sentiment classification, and it's just one of the many applications in NLP. Right. So these are very broad examples about natural language processing and machine learning. But the question, and also I'm provide answer step by step in today's class, is to think about, can we apply machine learning to predict users' engagement and like future engagement trends on social media apps, right? And that's a very interesting problem. But before we go into define this problem, I hope just to provide a little bit more context about what is users' engagement on social media. So again, I think feel free to interrupt me and raise questions. Either just voice out, or you can leave the text on the chat box. So Catalina and Katie can remind me if there's any questions. I hope to be we will have some breakout sections and interactions, but anytime if you feel like you want some clarification and you have some thoughts, feel free to speak out. So about the user engagement on social media, there's a lot of things we can talk about. So in a very kind of initial stage, we can think about any type of user activities or interactions with the app can be the indicators for engagement on the social media. For example, you can think about if they likes a post or a picture, that means some type of engagement. If they share the post, that means they feel like this post is useful or is worthwhile to share to your friends. If you put comments, or you post something, or you follow some other users, or even just click on the images, it indicates some sort of engagement. Of course, these different types of actions might indicate different level of engagement. Some are more engaging, some are less. Some may be just noise. Maybe you just misclick some images when you are swiping things. That doesn't mean anything. So there's some strong signals, some weak signals. And what I'm trying to define here as user engagement in social media, or you call it social media engagement, it's not a very single concept. It's actually representing all the possible metrics that are indicating of the user engagement signal. And you can be your own designer to define what is the right metric that you want to look at. So it's just a broad set of, it's just a high level concept that cover a broad set of instances. Right, so now that we know what is the possible ways to create metrics to indicating users' engagements, so the question here, or the main thing we're going to talk about today is how can we predict the user engagements in the future on the social media? And to be more specific, this means like when you are given a user's informations or like demographic informations, and also the user's past activities on the app, assuming you have this data, someone provided to you, can we predict the future engagement trend for the user? And I will be more specific about what does future engagement trend means here. But before that, I hope to first help you understand why this is a useful and important problem to consider. For example, if we can correctly identify a user's future engagement trend, we can use that to kind of classify or categorize users into heavy users or core users versus lightweight users or inactive users, right? Let's say if I have someone only using the app once, twice every month, that's likely an inactive user. And if I have another user that is opening the app and spending 20 minutes to an hour every day, that's very likely a heavy user. I would do very different things to these two kinds of users. For example, for heavy users, like a company might think about how to retain them. So I want to keep them active so that they can create more interesting contents that can bring more friends to our app. I may generate some revenues because advertising through those users. And for those inactive users, the top priority would be more like how to activate them so that they have some motivations to come back to the app more often, right? I have to think about some strategies to help those users understand why you want to use, say, Snapchat and what are the new features we have. If you use the Snapchat, I may have some incentives for you, things like that. Yeah, and also we can understand, try to have these more follow-up studies to understand why this, what are the differences between the group of inactive users versus the group of core users or heavy users. Is there some demographic differences, or is there some marketing strategies that are doing differently over these two groups of users? So there's a lot of follow-up things you can do if you understand who are the core users or who are the lightweight users. And that's a very important application for predicting the user engagement in the future. Another very interesting is more relevant to helping you produce, helping you iterating and building a better product or the app. Let's say every time you add some new features or you remove some features or you just change the interfaces of your app, you will create a lot of chaos. Some people just bump up and say, oh, I don't like it. Some people say, I like it very much, right? And by understanding the user's engagement, once they see a new version of the app or any modification to the app, you will see like whether the changes are plausible or it's not well received. That's also very useful feedback from the user. than just simply asking or posting surveys to every single user, and you would not probably expect a lot of responses in that cases. Right, so we talk about the task of predicting user engagement and why it's important so far. And this actually applies to many different social media apps. But to make the classes today to be more focused, I would say we will try to focus on doing all these like later practice exercises and discussions over the Snapchat app. I would create a scenarios for you, and by assuming it's actually an app developer for Snapchat, meaning that you have freedom and access to all kinds of user information and data, the user demographic information, how they are using the app every day, what kind of action they do on the app, what time in the day they do what, right? These kind of things. Just you can be very creative here to think about what kind of data people will, what kind of signals and data you will actually, let's say, record when a user using the app. In fact, also sometimes surprisingly, very subtle, tiny actions you are performing on the app, like just making a click, switching from one thing to the other, will actually be locked down by this social media app. And they become the data. Of course, you have the privacies. This data won't be released to others, but they will be used if you agree on, let's say if you click agree on some kind of privacy agreement, likely it means that you agree to share the data to the company for improving the user experiences. And that's what these data are being used for developing. But back to the question here, assuming you have this data, so I'm trying to have a more concrete definition on what is the prediction task of user engagement looks like here. So I'm posting a question. Can you use all this information and data about a user to predict whether the user will still use the app after a month? So this is kind of like an equivalent description to whether the user will still be active after a month. So this could be one, let's say, user engagement metric that many companies are looking at. So we call this like predicting the return users. And this is definitely complementary to predicting whether the user will like something, which are two kind of a microscopic. Predicting whether a user will return will help you understand in a very high level if this will still be an active user in future, so we can do something about a user. So that's our kind of a scenario. And to help you understand a little bit better, if you are not familiar with Snapchat app or not using them before, so here's kind of like a very three most common interfaces you will see on Snapchat app. On the central is basically the main interface where you can take the snap, basically a short video or a picture, and you can apply a bunch of filters, you can add text. So in this interface, you have a couple kinds of actions you can do, like creating snap, swiping the lens, save the snap, but not sending out yet. You can send the snap to someone, and you can actually post the snap as a public story. So everyone on your, every friend of your Snapchat can see that as a public story. So there's a couple of things you can do on the interface in the middle. On the left-hand side, this is actually the interface for seeing all your friends. From here, you can click on the friend, you can create a chat, you can view the chat, they send it to you. You can view a snap, they send it to you. You can create a snap from this interface. You can send a snap that you already saved in your in your album as well. And on the right-hand side, this is usually the what they call story interface, where you can see all this public snap or the snap created by some influencers or some companies for general purpose. You can view story there. You can discover some public snaps created by those influencers, right? So these three interfaces contain not disjoint, but an overlapping of different actions you can perform. And usually I would call the middle one as more like a content generation area where you be creative and you create something out of there. And on the left-hand side, you are more specific to each user. So you are doing some one-to-one communication. On the right-hand side, it's more like you are receiving public information and you are also sending your information to the public. So it's more like broadcasting scenario. Any questions so far about the Snapchat interfaces? Great. Okay. So then here comes our kind of breakout and brainstorming section. So we talk about what is the user engagement predictions, and we define a more specific scenario. Assuming you are an app developer in Snapchat, you have access to the user data and information. And the goal right now is for us to build a model to predict if the user, a specific user, will come back in a month. So we don't know anything, we don't know what will happen between now and in a month, but we know what happened to the users up to now. Let's say this is a user has been using Snapchat for the past 3 months or a year, right? So the question for you at this breakout section is, what do you think are the useful signals or informations that we can leverage to predict whether the user will return in a month, right? I think Katie and Catalina are gonna help me form groups of 5 or 6 students, and they will be sharing a link to a Google Doc where you can put down in a group, in each group, you can put down a couple of bullets of some just thoughts that you think those will be informatic signals that we can leverage. Any questions about the question we're gonna ask for the breakout section? Awesome.
So Catalina has set up the breakout rooms. We've mixed you up so that not all of the computer science people are in the same room. Again, even if you are an environmental or biomed person right now, this is really just about exercising that logic and trying to think through something. So Catalina is going to send you to the breakout rooms. Professor Ren, I will have to
activate you if they think you are not an active user. Like sometimes you see in email say, oh, your friends having updates, like probably from Instagram or TikTok. Those are likely the cases where you haven't been logged into the app for the past couple of days, and they feel like you are an inactive user. They are thinking about how to attract you back to the platform. Cool. I think I should, yeah, share the doc, and then we can talk through this a little bit. Yeah, so should I restart it? I mean, is everybody back?
I think so.
Cool.
Yeah,
okay.
Go for it.
Okay, yeah, so well, I see a lot of ideas here. Let's kind of went through it, and then I will share some of my thoughts about what Snapchat is actually doing for their products. So in the room I was chatting with, I think it's the 3rd room. I think they, yeah, like number of friends that you have, it's definitely an indicator. how often they visit Snapchat, what time they visit, how old the user is, like some demographic information about users. Those are definitely relevant things. Similarly, I think group 2 talks about, what are they using it for? Basically, like the amount of time they spend on different features on the app. That's very good. Also demographic information like age range. Yeah, so this is an interesting one. So how much other social media they use. So this is actually not the data that Snapchat can collect for the user because they don't know how often you are using other app. But sometimes they can actually purchase some of the statistics about in a population level. Let's say there's some companies dedicated to collect user statistics about, okay, on this segment of users, how much time they spend on, let's say, TikTok versus Instagram, Facebook, Twitter, and other stuff. Yeah. So those are not the Snapchat data, but you can still try to get those data from other sources. And let's see. Yeah. So the group 4 talks about screen time. That's the app usage time, number of posts, chats, like the frequency of the content generation, where they are, actual school. It's an interesting one. I don't think Snapchat collects this when you register the app. Yeah, time of the year for sure. If it's actually, I did a very interesting research on seeing during the summer vacations, the whole user patterns changes. They start using the app a whole day long versus before school and after school, right? So the patterns swept not only just in US, but also in Europe and other countries. And it's very accurate because different countries have different summer break starting time. So you can see the slide like 1 month shift difference between different countries there. And other groups talks about, also the frequency of using the app, the time they spend. This is using cookie. I think it's likely from computer science background students. Even for me, I don't know too much about cookies, but I know this is a way to check the users on the internet in some sense. So once you come back, this is the same user. Cool. Yeah, I think every group providing sort of new and also overlapping informations about roughly what is the user like and how they are using the app. Okay, so let me go back to my presentation and share a little bit about my understanding of what Snapchat is actually doing for collecting the signals. Right. So the first kind of signal Snapchat actually used, I call it user profile. And most of these informations are already collected when a new user sign up for Snapchat. Let's say you see this screen, they will ask you date of birth, and then they can basically calculate your age. And sometimes they ask gender, and this could be optional. So it might be a missing information for some cases. But one very interesting thing I hope to tell you is different companies are building what they call name classifiers. They can use your first and last name to predict the gender of the user. And this is sometimes a controversial thing because it really depending on how they are building the classifier. But this is what really happening in some of the companies. They're using first and last name to predict the gender. And this is also one way the machine learning can be used, but might have some societal problems as well. Country and locations, they can actually use your phone GPS without actually asking you. And your location can be constantly switching, and they will actually detect those things and try to use that patterns to understand you better. And the length of usage is basically like could be starting from your registration time up to now, or could be the last time you are actively using Snapchat and until now, and number of friends. So those can be collected automatically. So these are the user profile. So some of the interesting statistics I want to share before I go to the second category is that actually up to date, the number of snaps in the Snapchat app is actually a huge amount, like 200 million snaps are created on Snapchat every single day. So that's a very big volume and shows a lot of engagements from different users. And there's also some like on the whole Snapchat platform level, the age distribution, and more than half of the US internet users from age 15 to 25 is using Snapchat. That's also a very kind of interesting statistic. And in terms of the gender they could collect, I think this is not specific to US. This is probably for the entire all over the world. I think Snapchat users are 61% female versus 38% male users. And this is a statistics I think collected in 2019. Things could change, I guess. Okay, so that's about a user profile. Another important category of signals that Snapchat are actually using is the activity patterns of the users, because we know like right now every month there's the total active users in a month is like 300 million for Snapchat, and the daily active users is like 190 millions. So meaning that every day there's a significant amount of users are spending substantial time on Snapchat. So these could refer to signals like how often the user is opening or using the app, and the time durations for the app usage, and what time in a day or a week or in a year a user like to use the app. I see all of these answers in the bullets by different groups. I think that's awesome. And again, some statistics actually about these different aspects of features. But these are the population level. They are not specific to a certain user. So the number of Snapchat, the snaps created in a daily time is like 3 billion. And the number of times people view videos on Snapchat is 10 billion in a day. The app usage in a day is like 20 plus times on average. So they open the app, close open 20 times on average for the Snapchat user. And every time when they used, every day, the time they spend on the app on average is like 30 plus. I think there's a typo. So should be minutes, not times. So that's a very impressive number and give you some idea about what is the average user looks like when they're using Snapchat. And the third category of signals, it's actually, I think, a new one that I was trying to work with the Snapchat engineers to look into and explore more, which is what we call in-app usage behaviors. So, and in this category, so the kind of signal we look at is what kinds of actions a user like to do when they are using the app. This is on a very micro level. Like what is the first thing a user likes to do when you open the app, right? Some users like to just view a chat. After the viewing, they might just reply to chat and then they just close the app. But versus other users might be opening the app just to see scroll to the discovery page and then start looking through all those news and short video clips. And that's a very different usage pattern. And some more detailed questions can, and also corresponding different signals is like whether the user tend to view content more rather than creating content or the opposite side, or they are equally liking both, right? That also tells a lot about a user, whether this user is more like a content creator versus just a content, just digesting content most of the time. Right. And yeah, basically in this category, we want to understand better the usage pattern for a user. And regarding this category, there's actually some interesting resources you can find out online by comparing what users usually tend to do on different social media apps. Like on Snapchat, the most frequent thing is just talk to my friends by sending snaps or sending chats, sharing photos, sharing videos. But on Twitter, very likely you are checking very recent events, news events. You check some discussions, or you follow an influencer and celebrity. On Facebook, it's like talk to friends and family, share photos. On Instagram, it's definitely prioritized for sharing photos, but less of talking to friends, follow influencers, celebrities, things like that. On YouTube is viewing videos for sure. It's the top priority. You won't be chatting too much. You won't be creating snap there. So these are different usage patterns over different platforms. Cool. So now we will switch the gear a little bit and start talking about a little bit more machine learning terminologies. As you know, like all these signals we've been talking about, we express them in more like a conceptual level, like more like a qualitative descriptions, right? They are not yet very quantitative measurements or metric. And usually we will use a term called feature to describe in individual measurable properties or characteristics of a phenomenon that are being observed. This is kind of might be a little bit boring term, but what it really says is like you can come up. So the qualitative descriptions doesn't equal to quantitative measurements. And why we need quantitative measurements is that because we need to rely on our computers or machines to understand and digest the information. So we need to make sure they can be translated to some numbers, numerical numbers or quantitative measurements that can be further compute and model. So now that we see a little bit about what is features, so I want to give you some examples about how we can translate these qualitative descriptions that we've been talking about in the signal section into some possible features that can be quantitatively evaluated and measured, right? So for example, in the user profile category, we talk about how old is the user, what kind of user it is, how long the user been with Snapchat, and the time durations of app usages. Some of these are sort of already quite quantitative, but I think what kind of users is definitely a very qualitative description. How long the user been with Snapchat is also a little bit vague because you don't know exactly. There's many ways you can compute this so that you can come up with multiple different features. So let me show you some example. So how old is the users? I think it's an easy case. You can just map that into age and what kind of users you can talk about from many different angles, genders, countries, other stuff you can think of. A length of the app usage by month, it's a more concrete feature for describing how long a user has been with Snapchat. And the time duration for the app usage, you can come up with different things, but one of the possible feature is in using minutes to describe how long a user will use the app per day in the past year or month. So for each of the feature here, you will have many different possible values for different users, right? Like for these particular users, the user can be 15 years old and can be using the month for 15 months already, and the average usage time per day is 20 minutes. So these are just one set of possible values for the corresponding features we are talking about here. Okay, so that kind of leads us to the second brainstorming and discussion section. Now that you understand a little bit better what do we mean by features, which is the quantitative measurable um, metrics or values. And there could be multiple different features under one signals that you can think of. So can you come up some designs for of features that can predict users' future engagement trend, or the same as like whether the user will come back in a month? So I think we can take this question and then go back to the breakout section and discuss a little bit. Put on your thoughts on the Google Doc. Some of the thoughts here. Yeah, let me know when we have everyone here. I think we are still.
Okay, everyone should be back in now.
Great, cool. All right, so yeah, so I think this part is actually very interesting, because when I was having discussions with one of the group and also viewing the answers, I see some definitely correct answers, but some of them are I think might be still it's unclear what does this quantitative measure or the feature means. So let me provide some concrete examples here to help you understand. About a user demographic or the user profile part, I think it's relatively easy to come up with the feature, and then the value will be also easy to grab. For example, when you're asking the age, the gender, the length of the app usage, whether user for a number of friends, those are easy to collect, right? And let's talk about more about user activities, right? Let's say if one of the signals we're talking about is how often a user open or use the app, right? So I can actually come up multiple different features that can be quantified along this line. One is I compute the number of app sections. Like a section basically means a significant chunk of time that you are using the app. So you might have many sections per day because you open the app in different times. So the number of app sections per day could be 4, and the number of app sections per month could be 100. So these are actually two different features, although they are very similar to each other. And then if you look at duration of app usage, I can compute that for average length or minutes of a section. And I can also compute the total app usage time in a day. So these are the two different features, but all talking about the duration of the app usage from different perspectives. And they have different values, right? So finally, if you look at what time in a day or week a user like to use the app, one feature I can come up with the most likely time segment in a day the user tend to use the app. And the value could be 6 p.m. to 12 a.m., this 6-hour window. Let's say we partition every day, the 24 hours into 4 different windows, then this is the last window of a day, right? Some of the people might be using in the second window of the day more than the others. So these will be different values. In-app usage, similarly, when you ask about what actions a user like to do, I can create a feature like whether the most likely action is send chat. And the value of this feature will be either yes or no, or in a computer language, it's either 1 or 0. So it's black and white, right here. So what is the first action user like to do can be whether the most likely first action is view story, and also you have yes and no as the two answer options or the value options for this. Similarly, if the signal is trying to ask about what kind of usage pattern user has, one of the features could be percentage of the time spent on content generation. And the possible value of that could be any value between 0 to 100%, right? Like, and what kind of usage pattern the user has can have another feature. This can be very creative as long as the feature can be quantified. For example, I can come up with a ratio of the time on chat over the time on story, right? Because some of the people just like to use chat, the others just like to use story on Snapchat. And you might have a ratio, again, between 0 to 100%, depending on you are more like a heavy user on chatting or a heavy user on story viewing and generation, right? These are some examples we see so far. So let's assume that we have these useful features which can be quantified. Now, the next big question is, how do you build a model to predict a user's future engagement trend? And to make that more specific, let's say, can we predict the user's chances of returning, or COR, after a month? And this quantity gonna be a value between 0 to 100%, right? So what we're gonna talk next is, so we have so many features we just see in the tables right now. And if every features, you can have some values for different users, right? How to combine all of these features to predict the COR, or the chances of return for a specific user, right? Like basically how you compute those features together and get a value between 0 and 100%. So we can use a very toy example. Let's say we only have these 5 features, and I know the value of these 5 features already. The age of the users, which is 18 years old, the number of app sections per month, which is 200, the total app usage time in a day, which is 50 minutes, the percentage of time spent on the content creation, which is 60%, and the last one is whether most likely action for this user is send checked, and the value is 1, which means yes for this specific user, right? So I want to just quickly pose the question of what do you think could be the possible way of combining these features and predict that COR value between 0 and 100%? Anyone has any idea?
Can you first proportion each value and then you weight it according to how much that value is important?
Yeah, great. I think you talked about 2 aspects I'm going to talk about in a bit. So it's perfect answers. So as you can see on this table of these 5 features, every one of these has different value ranges. The ages is like from 0 to over 100, but the number of app sections per month could go very high for different users, or as little as 0. The app usage in a day maximum is 60 minutes times 24 hours, right? So you cannot go beyond that, theoretically. The percentage of time spent on content generation is gonna be a 0 to 100%. So it won't go over 100% for sure. And the last features, the value is only 1 and 0. So they all have very different ranges, and they might have different importance as well. So I asked this question. So here I just want to introduce a single terminology very quickly, which we call normalizing the feature, or feature normalization. And this is what I think Jacob mentioned as proportion different values to a comparable ranges. For example, I can transform 18 years old by taking over 100 and then get this numerical value of 0.18. I can do something similar for the others. Let's say the maximum app section per month over all of the Snapchat users is 1,000. I never see any user go beyond 1,000. So I would just take 200s over 1,000s and get a 0.2, which is a numerical value that have a comparable range with other. Similarly, for the third feature, I would do 15 over 24 by multiply 60. I would go approximately 0.1. And the 60% will be transformed into 0.6, and the last one will be just 1.0. So all this value now theoretically is between 0 and 1. So they become more comparable right now. So this is feature normalization, and we kind of tackle the first challenge of how to compare different value and combine them when they have different ranges. Now, very simple model to create the chances of return response is just to add all those normalized values, x1 to x5 together, and then average over 5 because I have 5 different features, right? So that's basically like this. So we get a chance which is 0.416, which is 41.6%. That's a very simple model, assuming all of the features are equally important. And that's a very strong assumption because even human experts can know that some of the features are more important than the others, right? So can we have a more sophisticated model here by manually assign the importance of each features, which basically is a value between 0 to 100% for each of the feature value. Let's say I ask a manager in Snapchat about these 5 features, and the manager told me that, okay, I think feature 1 and feature 2 and feature 3 are equally important and they are like 20% each. But I think the feature 4 is a little bit more important than the first 3 features, and the feature 5 is not that important. So the manager will put 30% of feature 4 and 10% of feature 5, right? So notice that all of these features importance add up together as 100%. So by doing so, I have a different predictions for the chances of return, which is 37.6%. It's lower, but this seems to be a better model because we know which features are more important than the others by the domain expert, right? That's a better version of the model. But what happens in the companies right now is, no, I'm not gonna trust a single manager to tell me which feature are good and which are bad, because the manager can have some sort of biases and prior knowledge that doesn't consistent with the young users of the Snapchat, for example. So this becomes a more computational problem right now. Basically, we don't know what is the important score for each of the feature, like the question marks here, but we can make them variables, W1 to W5, which is basically the value between 0 and 1. And we also ask W1 add to W2, 3, 4, 5 together equals to 1.0. So basically we are solving an equations. In order to solve this equation, we need some examples. Let's assume we have 3 users in Snapchat. And the first users is gonna return in a month, and they have the feature value for X1 to F5 as follows. And I have another user that doesn't return in a month, and the user has a different set of feature values for the same set of feature. And I have another user return in a month and also have different features. But I'm gonna assume all of the features are weight the same across these 3 users. So you can see now we are solving a linear equation with COR like the variable y, and the feature values is like x1 to x5. So we are solving w1 to w5. Sorry, there's a typo here for the weight variable. It should be w4 and w5, right? So and that's just linear algebra, and the linear algebra class tells you how to solve this equation, and finally we get the value. Okay, w1 is 15%, w2 is 20%, and so on and so forth. And this is exactly the feature importance that you can learn from the examples or the data. So this process is just basically the example of machine learning, how the machine can learn the importance of the features or a model from user data, right? Okay, so up to now, I want to just summarize. I guess throughout the whole course today, I talked about basically a recipe for building a prediction model for predicting the future engagement trend. And this recipe have 5 elements. One is we need to use our human knowledge and domain expertise to identify useful signals. And I think as we demonstrate today, users actually have pretty good intuitions for identify useful signals. And then there will be some domain expertise kits in, like how did you come up features to capture the guiding to intuitions for the signals? and normalize the features to have consistent value ranges, and weight the features either manually or by learning from the data examples as I just showed, right? So these are the 4 important elements in this recipe. The same recipe actually can be applied to solving other societal problems. And that's actually the most exciting part about machine learning in the current research frontiers. For example, detecting fake news on social media platforms is also implemented by machine learning in all these different companies you are seeing right now, right? I can come up features like whether the users have trustworthy friends, whether the contents are following certain grammatical patterns and things like that as features, and I can build a model as what you just saw now to detect fake news. All right, basically input a news articles, output a variable, either is 1 meaning is fake news or 0 meaning is non-fake news. Or we can apply the same recipe to solve fraud detection problem. The input here is basically a transaction, and this transaction, let's say I'm gonna swipe for $500 on this credit card. But how would the bank automatically be alert about these transactions is trustworthy or is some kind of fraud attempts, right? Sometimes your phone will receive messages saying this might be a suspicious transactions. Do you want to confirm? And you can type in yes to confirm. That's what these fraud detection algorithms is running behind. Collect some features about its transactions, about a user of the credit cards, and all the other things, and output a probability score quantifying how likely this is a fraud detection. Right. This is just another example of applying this machine learning recipe to solve a different societal problem. Right. So I think that kind of concludes my class today. I hope that this machine learning recipe I shared today can be inspiring for you and could help you think about other places that machine learning could possibly apply and solve these big problems, which might be very costly for human to manually solve them one by one. And I have created a very little survey for the class, which you guys can check it. I think Katie will share the link by emails as well. You guys can just check it and maybe finish by the end of the day as you see fit. I hope that survey can help you review the key concepts that might be useful for your future study. All right.
Can we open it up to any questions, Professor?
Yes. Happy to answer questions.
Does anybody have any questions? This is very similar to how we choose you in Shine, except that we do it manually. We don't do it.
Yeah.
We don't do machine learning. We don't have enough data to. We can do it manually, but we have a rubric. We give you a number score. And we have certain things that we like our personal statements. We weight more than your grades and stuff like that, but we do weight your grades and your SAT scores just because we don't want you to be a really, we want you to have enough academic discipline that you don't fail here, because it doesn't do anybody any good to come here and then feel like they're not up to it.
Yeah, in the future, maybe the admission of college can be automatic in part, as long as we have the data. I think the problem right now is a lot of aspects of a candidate student is not really described in the data that the machine can digest. Like, what is the life experiences of the kid up to now? It's not in the data. Only the kid can express in their personal statements or by interviewing, right? Maybe one day the natural language processing systems can be smart enough to fully understand the personal statement, then we can do the screening in a sort of automatic way.
I have a question, and I know that several students had to leave at 3 because they had set up times with their mentors. But I stopped using Facebook about a year ago. So I'm very interested in democracy. And so I understand that using machine learning for fake news is really important for democracy. Do you think that Snapchat or any of these other uses contribute to democracy? Or is something like Snapchat just very useful to you as a researcher to get to the larger issue, which might be more important to you, which is fake news and hate speech?
Yeah, that's a great question. I think this is exactly what these social media companies are investigating a whole ton of resources in solving. We know that in the last two or at least one presidential elections, social media platforms played a huge role in surfacing or pushing the content to the user in a very implicit way. Like when you read through your Facebook news, you see those apps, you don't really know why those apps are recommended to you, but they seems to be suitable to your personal values. And they also kind of slowly influence what you view about these candidates and their strategy, right? So I think this information, it's hard to say this is a good or bad in one shot summary, but I think this becomes a very important mean for these, let's say, different parties and different candidates to actually influence users' opinions about themselves. And fake news is even more harmful because they can easily change your attitude towards a country, towards a race or something like that. And that's the last thing we want to see. But it's really hard to control, as I said. If you don't have a trustworthy machine learning model, it's impossible for human to scan through every single post. As you can see, even on Snapchat, there are 300 millions of videos posted every day. None of the companies can hire a million of users, a million of curators just sitting there and screen through those things. So this has to be done in an automatic way. But if the automatic way is not mature and it start falsely annotate or detect fake news, it's still useless, right? So this is still the frontier of the research we are doing now. How to make the fake news or hate speech detection algorithms on these social media platforms to be transparent. We know how they make decisions, and to make them accurate, and also to make them non-biased. They won't just classify a news or a social media post just based on some keywords or of genders, of races, right? So these are still the important things we are tackling right now.
Think you. Do you feel that you express yourself and your values in your research?
So I think my research is trying to span across two sides of the spectrum. One side is application of society, which have societal impact. For example, I do research applying my machine learning techniques to solve hate speech detection, to debias hate speech algorithms. But I also do research, solve some fundamental problems, like, for example, how to estimate those feature importance in a more efficient and effective way. So that's very general research that can apply to many different applications. So I hope that I think 40% and 50% of my research efforts can demonstrate societal values, and 50% of them is generic and can have broad applications. Yeah.
Thank you. Any other questions? Doesn't sound like it. Okay. Professor, also somebody sent a chat saying that in the survey, the text box answer only accepts a number. So
Okay.
You can change that after we let you go. And would you all join me in thanking Professor Ren for this really interactive discussion today?
Thank you. Thank you, guys.
Thank you so much.
Yeah, I really enjoyed the time spent with all you guys. I hope this is helpful and inspiring. I look forward to interact with you more in the future. See you guys.
Bye.